iteration and recursion. We're going to start straight off with an iterative loop in VB.NET. We're going to look at a factorial, all the numbers that make up the factorial 5, the total being 120. So when I enter 5, I'll just stop that from a previous run, there we go. When I enter 5, it should list all those numbers to reach the 120. So there we go, 5 times 4 is 20, 3 20s are 60, 2 60s are 120, multiplied by 1, we end up with our 120. So 5, the factorial is 120. Let's see how the for next loop works, because iteration is a loop. It's simply saying every time we pass through this particular loop, we're going to count it. So every time there's a read line, we've just done a read line there. Whoops, back out there. Let's go back to our loop. Yep. Every time we go through our loop, we will count it. And that count will be equal to the variable I. And then our step will be less 1 each time. This is interesting. Every time we count it, it's going to be less 1. So we've got 5, 4, 3, 2, 1. So we're using our starting value of 5 in the same way we use our count, by subtracting 1. So it's a very clever and efficient little loop, this. And all I've done is said, let's see what each value is for each loop. So we're actually going to write that in the console. And of course then we're going to end up with our total. Without this little line, incidentally, we will not see the actual numbers 5, 4, 3, 2, 1 for our factorial 5. Okay, so what's all the fuss about recursion and iteration? We say them in the same breath because they both do the same thing, which we'll see in a moment, and one has benefits over the other, and you can use them both very efficiently. There are faults with one and not the other. Let's have a look. Let's consider recursion. There is a limiting condition with recursion, and that is making sure it does not have infinite loops. So you must terminate the recursive function, and you've got to test this to see if any condition is unsatisfied. This means, is there any possibility that you will not be able to get out of the loop? And of course we'll talk about this later, but this is Stack Overflow. What happens is that memory, called stack, or stack frame, is assigned to this kind of a function, this kind of a process, and the memory that gets assigned by a computer to this process can simply overflow. In other words, the program will crash, and we'll demonstrate that in a moment. Efficiency. You can almost always substitute a loop for recursion. So we'll show you another example right now of that same factorial as an iterative loop. There it is there. Alright, now let's show you as a function now, that's what I mean. Let's have a look at this as a recursive function. So here's our little function that we're going to call, and remember this is called framing or stack framing. So we'll send this part of the program back to our function called factorial each time until the condition of 1 has been met. Let's run this. It doesn't show you the steps, it just shows you the total. So the total of our factorial 5 is 120. I could make it read out all the steps, but in this example I'm just going to demonstrate what Stack Overflow is. If I change my factorial to 0, you'll notice my condition to exit out of the recursion, I called it a loop accidentally. I mean it's recursive referral. It refers back to this method that has been set up. The condition here is that when n equals, or if n equals 1, then simply return 1. In other words, we've ended the list of numbers that make up our factorial of 5 in the first instance. Now we're going to try 0. So I'm going to run that, and there we go. It says Stack Overflow exception error, Stack Overflow exception handle error, so unhandled, and we just simply have to terminate that. Alright, it doesn't know where to put the extra loops, which are now going to be infinitive. Whoops, said loops again. I mean recursive referrals, if you like, or recursion. It doesn't know where to put that stack framing. It's just used up the memory in those milliseconds with 0. Okay, let's go back to our considerations. So number 1, again, we cannot have infinite loops. There must be a way to exit out of that. Oh, that's also referring to a loop, but it is a kind of loop. So memory usage, what happens? Essentially, each time a procedure calls itself, it uses more of the local variable space for additional copies of its local variables. If this process continues indefinitely, it eventually causes a stack overflow exception error. And there's a diagram on page, I think it's 91 in your textbook. No, sorry, I beg your pardon, 81, that describes this fantastically with little frames. Efficiency, you can almost always substitute a loop for recursion. A loop does not have the overhead of passing arguments, initializing additional storage and returning values. Your performance can be much better without recursive calls. What does that mean? Well, just compare the programs. This is our function we set up. Every time it's doing, it's calling Factorial, it's referring back to the method we set up and creating space for it. Whereas our loop, there we go, our loop just simply passes through until a condition has been met. It's extremely simple in terms of memory usage. There's no passing. Now, what do I mean by passing? Passing means taking the value and sending it back and seeing what needs to be done with it, and then passing the new changed value back to our main routine here. So there's a lot of throwing back, throwing forward, throwing back, throwing forward. That's recursion. Recursion isn't necessarily bad. This is just to show you that what can be done recursively can be done on a loop. And it depends on your condition. This is no good, because what happens if we use 0? We're going to have to use, is it less than or equal to 1? Let's see if that works. Yeah, there you go. 1 is returned because 0 is already less than 1, and that's the only way we can get out of this problem in this particular argument. I'll put that back to 5, save it, and move on to... Okay, so memory usage, we know that memory gets assigned. It's called the stack frame memory, and it has a limit, and that's all you really need to know there. Efficiency, well, you can do a loop instead of a recursive function. It just depends on what you need done, and it very much depends on this. If you're going to write a recursive function, it has to have a limiting condition. That's worth a mark in the exam. Now, testing is important, and what they also like to put in exams is dry running a recursive function to see if there is some sort of limiting condition. So if you write a recursive procedure, you should test it very carefully to make sure it always meets some limiting condition. You should also ensure that you cannot run out of memory due to having too many recursive calls. So once again, this reminds me of what you've done in your big project, Comp4, where you have got data that is typically on the extreme, the boundary, to see if your program will collapse. I hope that in Comp4 some of you have used a bit of recursion. Certainly I'm sure you've used iteration, but this is great to put into your Comp4, by the way, this bit of information here as limitations. Right, so let's have a look at our function that we tried. Our function was called Factorial, and basically the condition was less than or equal to 1. We're just going to simply return 1, which is great because every factorial should end in the number 1. Else, we're going to return whatever number we've put in, whatever value we decide to assign to n, we're going to say it's n minus 1 times n. And we're going to keep looping, so it'll be 5 times 4, and then that total will be multiplied by 3, and that total by 2, and then that total by 1. It's very efficient, but there are limitations. That's a good answer as well in the exam. What's the great thing about recursion? Well, it's a very efficient way of writing a program, and the fact is we can call our factorial throughout our program module, so that's great, but the limitation is down to can we get out of it? Have we got a recursive function that is not going to result in a memory failure, which is what Stack Overflow is, memory failure. So, from your textbook, let's dry run it. These are just, when you dry run, and by the way, I hope you got a couple of these in Comp 4, but dry running your, whatever it is, it's just a means of testing it, and this is the number, or the test number if you like. In our instance, it's the number of loops going through with 5, factorial to calculate 5. So here we go. There's 5. Of course, we assign n. That is essentially that. It's in parentheses, so that gets passed to that. What's our method? Well, it's 5 times 4 because it's going to be n minus 1. The result is 5 times 24 equals 120. And then we just move through our call numbers, 1, 2, 3, 4, 5, ending in 1. This is a great example of how we know our recursive function will do what when it reaches 1? It will terminate. Right, let's move on. Okay, sorry, just before we move on, it's interesting how our call number goes from 1 to 5. Okay, that is obviously completely different to that. That's the number that gets passed. So the very first number that gets passed is our 4, is the result of 4 times 6, moving it up here, 5 times 24. These arrows should show that clearly what's happening. A great dry run table. Will you get that in an exam? Yeah, I reckon you will. And you would have to test it yourself or complete the table. Alright, let's see if we can move on here. Yes, we can. This is great. Also from your textbook, a fantastic way. I've called it stop calling. We know that when the recursive function reaches 1, the condition has been met. So it sort of unravels all these frames. This is just a diagrammatic way of representing stack framing. So this is our first loop, if you like. We like to call it a loop, that's fine. Or we should call it pass. If it's recursion, we shouldn't really call it a loop, but call it a pass. This is our first pass, second pass, third pass, fourth pass, fifth pass. And all the results that it's returning. Fantastic way. Have I seen this in the exam many years ago? Haven't seen it lately, but you might be asked to comment on what it represents. What does it represent? It represents a condition that is being met, so there's no memory failure, i.e. no stack overflow. Right, there's our iteration program, iterative program, not function. And what's the efficiency here? Well, there's a simple condition that loops until that condition's met. There's no passing of values back to a method like we had with our recursive function. It simply loops through and exits. We've done that, and that's the end of recursion and iteration, and if you like, the difference between the two.